Hello everyone. In the last videos we saw how we can find the time complexity of any for loop, easy or complex. But if now I will give you a while loop and you can't find the time complexity within 5 seconds, then this video is for you. By the end of this video, you will have a solid method you can apply to any while loop, any algorithm and get its time complexity. No memorization required, only understanding. So let's get started. So here is the first example. Here we have a simple while loop where I is initialized to 0 and it will run until I is less than some number n. Let's assume n is a large number. While this condition is true, a statement will run and I will be incremented. This whole process will repeat. So let's see how many times each condition runs. So initialization, it runs only one time, and this condition, we are checking only how many times this condition will run. So it's n plus 1 times. How it is n plus 1 times? Let's see. We also discussed this in our first for loop video. So let's assume that n is 5 and I is initialized to 0. So this is correct. I is 1 correct, I is 2 correct, I is 3 correct, 4 and finally 5. So here we can see that 0 condition is I is less than 5. So I is first 0 and n is 5. So yes, it's correct. 1 also correct, 2 also correct, 3 it will also satisfy, 4 also satisfy. But now if we see I is less than 5, which becomes here 5 less than 5, this condition is not true. This statement will not run. Then why did we write n plus 1 and not n? Because we are checking how many times the condition will check. How many times it will check the condition, not how many times it will execute. So yes, here we also counted this. So how many times this is? 6 times, and that is 5 plus 1. So n plus 1 times. Then this statement, as I just told you that this condition will check for n plus 1 time, but it will execute for n times. So here we have n times it will execute. Then this one also, I also will increment for n times because it's inside the while loop, and until the while loop executes it will be n times. So let's find the time complexity function here. It will be f of n equal to, it's 3n plus 2, 3n plus 2. This is our function. Now let's calculate the time complexity. It's big O of n. As in the previous videos, we discussed how we can find the time complexity. In order, in the parenthesis, we write the highest degree polynomial, dropping its coefficient and constant terms. So that's how we can calculate the time complexity. Now for just experimenting, let's convert it into a for loop. So what we can do? We can write here for I equal to 0, this initialization we have done, then I is less than n, this condition also done, and I plus plus, this incrementation also done, and here we can write statement our, and this is done. This while loop is converted into a for loop, and time complexity of this for loop you can directly say if you have watched my previous videos, that is order of n. Now let's see our next example. Here we have I initialized to 1 and I is less than n and statement. Till now everything is same, but here we have instead of incrementing, what we did is we are multiplying I by 2 every time. So let's decode it. Here it will be first I is equal to 1, then it will be multiplied by 2, which will become 2, then new I will be multiplied by previous I into 2, which will become 4, and we observe a pattern that it has become 2 to the power 2 into 2, which becomes 2 to the power of 3 until it is going, and it will keep going like this until it becomes I equal to 2 to the power of k. Now for our terminating condition, the loop will run until I is less than n. So the terminating condition will be that I is greater than equal to n. Now approximately we can say that I is equal to n. I is equal to n. This will be our termination. This will be our terminating condition. The condition where while loop will stop running, it will stop executing. So what is I here? Here I is 2 to the power of k equal to n. So if we take log 2 on both sides, this will become k equal to log n base 2. So for this while loop, we will calculate its time complexity in terms of k. This time complexity will become big O of log n base 2. So that's our time complexity. Now let's also convert this into a for loop. So here we will write for initialization equal to 1, condition I is less than n, and the forward condition which will become I equal to I times 2, and here our statement will come, and that's it. This is our for loop looks like. In previous videos we also discussed how we can calculate the time complexity for this case. Here is our next example. Here let's see. This condition will run only for one time because it's initialization. This condition will check for n plus 1 times. This statement will run for n times. Now let's see how many times this I equal to I divided by 2 will run. So let's assume that I is equal to n, that is a big number, and I is being divided every time by 2. So when it enters the while loop, I will become n divided by 2. Then again it will repeat, it will become I equal to n divided by 2 divided by 2, and this thing will happen many times until I is greater than equal to 1. So what we can say, this will happen for some k times. So it will be I equal to, so at some point this will become I equal to n divided by 2 to the power k. Now let's see our terminating condition. It's I equal to not equal to, it's currently less than 1. When I will become less than 1, this while loop will terminate, means stop executing. So approximately we can say that I is equal to 1. Then we can write, so we can say that I is n divided by 2 to the power k. So this will become n divided by 2 to the power k equal to 1. Sending the 2 to the power k there on the right hand side, it will become 2 to the power of k. Then taking log 2 on both sides, so this will become log n base 2 equal to k, and we have to find a time complexity in terms of k. So we can write here that it's big O of or order of log n base 2. As you can see that this is similar to this one, either I is being multiplied by 2 every time or I is being divided by 2 every time. The time complexity is order of log n base 2. Okay, now let's move to our next example. Here we have I and k, two variables, both initialized to 1, and this while loop will run until k is less than n, and while it's executing, it will execute a statement, k will become k plus I and I will increment. So let's see it here. Initially I is 1 and k is also 1. Then what will happen? K becomes k plus I. So k was 1 plus I was 1. This will become 2. And this time I will be 2 because it has been initialized after this. Now again k equal to k plus I. So it will be 2 plus 2 and I will be 3. Again it will repeat, it will become 2 plus 3 when I will be 4. So it will be keep repeating, and let's say it has happened for some n times. Here we can write that 2 plus 2 plus 3 plus 4 plus and so on till let's say some m numbers it has become. And what will be our terminating condition? It will be k greater than equal to n, and approximately we are taking it k equal to n. So this is our k, it will be equal to some n, and here to make calculation easier, what we can do, we will approximately make 2 as 1. So what it is? It is 1 plus 2 plus 3 plus 4 plus till some n equal to n. And what this is? 1 plus 2 plus 3 up to m. It is nothing but the sum of first m natural numbers. So it is m into m plus 1 divided by 2, which is here equal to n. Now to find the time complexity, we can drop all other lower degree variables and constants and coefficients. So this will become m square equal to n. Now taking square root on both sides, this will become m equal to under root n. And now we have to find a time complexity in terms of m, because we said that this k will contain some m numbers. So here the time complexity we can write as, in terms of m, we can write it as order of root n. So that's our time complexity for this while loop. Now let's move to our next example. Here we have a while loop where if it will only run when m is not equal to n, and inside of loop you can see that it is, if m is greater than n, m will be m minus n, else if n is greater than m, it will be n equal to n minus n, and will run until m is not equal to n. So let's see. Let's take an example here that m is a number 8 and n we can take as 2. So these are not equal, so it will enter in the while loop, and m is greater than n, so it will enter in this if statement. So what will become, that if m is greater than n, it will become m equal to m minus n. So next, the first time this condition runs, it will become m equal to 8 minus 2, which is 6, and 2 will remain 2 because nothing is happening now for n. This time, next time it will become 4 and 2. Next time it will become 2 and 2. So this time, so in this iteration both are equal. So this condition is false and this for while loop will not run. So here as you can see that this statement only executed for 3 times. But to find a time complexity, I am calling it approximately 4 times to find a time complexity. So from this we can say that this statement ran for n by 2 times. Also this is a function, we can directly use it to calculate the time complexity. So what it is, dropping all the coefficients or constant terms if there are any, this becomes order of n. So here is our last example. This algorithm does not contain any while loop, but I thought that this will be a good example. So let's start with an example only, taking n equal to 6. So here what will happen, this statement will not run because 6 is not less than 5, but this will run. And now at this point, after learning so much, we can directly say that these statements, else statements, time complexity is order of n. But what if n was something like 4? 4 is less than 5. This statement will run. So this if statement's time complexity is order of 1, because it will only happen for one time only. It will check and then execute this statement. This statement will execute for only single time. So what we can see here, that this algorithm has 2 different time complexities depending on the input. So in algorithms we have 2 cases or 3 cases, where one case is the best case where the time complexity will be the minimum, and another one is worst case where time complexity will be the worst, will be the highest. So we can say that the best case is order of 1, but worst case is order of n. That was all for time complexity. We spend so much time on how to calculate time complexity of any algorithm because later when we study data structures, you will not have to look it up or search it up on Google that what this means. Whenever I said that this data structure is of order of something. So that was all for time complexity. From next video, we will discuss how we can calculate space complexity of any algorithm. Thank you.